finding area under known curves using two-dimension geometry. So we need to draw the function in the given interval. So you have integral 5 to 7, 2x minus 13. This is actually straight line. So you can take help from the graphing calculator. So your function is 2x minus 13. Window you can set up. I have taken negative 5 to 10, but if you take 5 to 7 is still fine. So look at the graph. So this is the graph going like this. Now we see intersection in here. So we need to determine that intersection. Go to second, trace 240. Then move your pointer close to 0 from the left side, which is called left bound. Enter. Then move it to the right side of 0. Hit enter and one more time. So you can see 6.5, and you can easily see here. If you write 2x minus 13 is 0, then x is 6.5. So then we'll be taking two integrals. One is going below the x-axis, so that will give me negative, you can see. And the other one will be here. So then I draw the picture and show you detail. So you're looking for the area, the triangle below the x-axis. So you can see the base is 5 to 6.5, which is 1.5. And the height is here is going down, so it is negative 3. And then plus, I need to take the top one. 6 and 5 to 7 is 0.5. So it's 1/2, base is 0.5. And then height is 1 unit. You can check in the graphic calculator also. So further simplification will give you negative 2. So this is the net area actually. So that is actually represented by this integral. I'm going to second example. The second example is the integral negative 4 to positive 4 square root of 16 minus x squared. So if you identify the function, which is y equals square root of 16 minus x squared, is the semicircle, upper half of the circle. So you can go to the calculator, type your function, and then take your window, maybe negative 5 to positive 5, and graph it, and see that your graph look like this one. So this is the half of the circle, and the area will be, now we are taking 1/2 of the area of the circle, which is pi r squared. Radius is 4. So that is giving you 8 pi, and you are done. Example 3, we have integral negative 6 to 6 and then absolute value of 18 minus 6x dx. Now if you plot the function absolute value of 18 minus 6x, you can see right here absolute value 18 minus 6x. Fix your window and graph it. So graph look like this. So you can see when x is negative 6, if you plug it here, so 18 plus 36, that is giving you 54. And then when you plug here 6, so 18 minus 36, which is 18. So we have put the scale in here. Now when you're looking for the area of the region bounded here, so you can see that intersects here at 3, because if you write 18 minus 6x is 0, you get x equals 3. So then we have one triangle here. The base is 9 units, look at here, and the height is 54. So you can easily find the area of this, and this one is base is 3 and height is 18. So find these two areas and add them together, because we have absolute value sign. So after simplification we get 270. We are now taking another example, integral negative 6 to 6. Now our function 18 minus 6 absolute value of x. So we need to plot this one in the graphic calculator and see how the triangles look like. So let me type the function. We have 18 minus 6. For absolute value sign, go to math, and then for numerics click 1, you get absolute, and then write x close here. Now we'll fix our window and graph the function. So we see basically three triangles. One is here, another one is going here, and the third one will be this. So let us check these values. So when I have x is -6 or +6, let's go with the trace. You hit -6, that gives you -18 here, and so other side should be -18, I'm sorry. So it's -18, and in the top you have x equals 0, that gives you 18. So we have all the measurements. Now when you're looking for the triangle here, the area will be 1/2, base is this, and the height will be this. So we take the measurement and put it as area of a triangle. So we got 1/2. This here length is 3. That one is -18. Also you can say that this triangle is below the x-axis, so area will be negative. That side will be negative, only this one will be positive. So the triangle in the middle, length -3 to 3 will be 6 units, and the height is 18. So you take 1/2 times 6 times 18, plus the other one here, 1/2, 3 to 6, length is 3, and that length here is -18, you see, from the scale. And then after simplification, you get 0. So this is the net area represented by this integral.